Hello and welcome to In2Infinity Eye-to-Eye Broadcast with today's topic called Fractals and Infinity. So you probably have been watching the sky at some point in your life. Wherever I'm looking, it's going on until infinity. But what is infinity? And where do we see infinity besides the big space above us? Yeah, this is the topic today. And let's explore what else, what other riddles are hidden within infinity. Yeah, fractals and infinity, what is it? And there's a very beautiful image in the backdrop of this title. Yeah. It's actually a geometry where you can already see that actually even in geometry you can find the concept of infinity. But why is it actually important? Well, just have a walk and look outside in nature. You probably notice that there are a lot of patterns from the flowers, the grass. I mean, there is patterns everywhere. And within those patterns, actually, you find infinity. Like, for example, this broccoli you can see here. I'm just going to put the pointer. Yeah, over here. Yeah, there's an infinite pattern that just repeats on every scale. So nature actually embodies concepts of infinity everywhere. Yeah, you just really have to look. And there is actually a proper name for it. They call it a fractal. Yeah, so a fractal is basically a pattern that expresses itself into infinity. But why are all these patterns and what actually makes them so infinite, right? Or so, repetitive? Well, in a sense you could say, and we're talking about this a lot, but geometry is in a sense the universal language of nature, but geometry itself is numbers in space. So you could say that universal geometry, sometimes also called sacred geometry, is like nature's patterns express themselves through numbers and shapes. So obviously the beauty you see outside in nature when you walk through forests or you're walking on grass, you see that the flowers exhibit certain patterns. And these patterns are actually just an expression of numbers. Now, obviously, the way numbers work themselves, you will see in a bit, they can actually then express different types of infinity. But what is, in a sense, a fractal? Yeah, a fractal is a self-similar pattern. And the unique thing about a fractal is it is observable at any scale. And in a sense, for mathematics, it's kind of like an algorithm. So you see here, for example, this is a fractal line pattern that you see in nature. Yeah, for example, the thunder or the branches of a tree, or right here, the river. Sometimes you can see it also on the beach. Yeah, when the water comes to the ocean, you see a lot of arms of that water, and it actually exhibits the same kind of fractal pattern of branches going off. Even in a sense, your own lungs have the same pattern. Yeah, so your lungs, they go into branches and they break off into branches and so on. So actually each branch has the same properties than the whole, just like a tree. And here you see on the right hand side how actually geometry is in a sense like a template. Yeah, you see there's a lot of triangles, and in one perception it looks like a very geometric shape, but if we rotate it up, it actually resembles the structure of a tree. So the geometry is in a sense kind of like the underlying pattern, and beyond that is probably just numbers themselves. But what kind of, these fractal line patterns, which is in a sense repeating into infinity, what is actually infinity, right? If something repeats into infinity, what kind of infinity actually exists? And we would say there are basically, a couple of different types of infinities. And these are our introduction into infinity in terms of shape. So let's say one that we're really most familiar with is, in a sense, the infinity, just going out. So if we look out into the sky and we don't see the stars anymore, just the blackness of the sky, we can imagine that it can go on and go on forever. And we would call this the infinity out. And in a sense, you could even say it goes out, but it actually even expands in scale. And this is what we could call the infinity out, over here. Yeah, it's actually something, in a sense, mathematically or geometrically, you could say it's just something like, if I open my drawing compass and open it up, it's kind of like that that kind of function. Yeah, it just opens up into infinity. And to this, there's actually something that is the opposite, which is the infinity in. Because just as we can look up into the sky and we can go further and further away and bigger and bigger and bigger, we can do exactly the same thing going inwards. So in a sense, you are like a dot. And we can go towards that dot, at least in our mind, and we just imagine we're going through the layers from our organs, the body, the organs, the cells, into the atomic realm, into the subatomic realm, and just going smaller and smaller and smaller and smaller, and it will never stop. So infinity means it never stops, but this is a different kind of infinity because something goes smaller. And then we have two other types of infinities, which you can find actually 3 types, you can find in the circle. So a circle in itself actually compasses already of infinity. And there are several reasons for that. On the one hand, you could say a circle is actually the biggest 2D shape because you can put any other shape inside, like a triangle, that's actually the smallest 2D shape, a square, a pentagon, a hexagon, heptagon, and so on. You can all fit it inside of a circle. But the circle itself is, infinite. You can put infinite lines, infinite diameters, in a sense, going through the circle, which would define the corners of the circle. But there are actually infinite corners, and we know that because to understand the circumference of a circle, we will have to work with pi, which is, again, an infinite number. And just as there are infinite insides of a circle, the same you can say as the outside, because you can draw these so-called tangents in mathematics, so lines that just touch the circle, and that's infinite as well. So we know that the circle is infinite inside and infinite outside, and not only that, it's actually infinite going around. Because think about rotation, right? The Earth is rotating around itself, the Earth is rotating around the sun and the whole solar system is rotating around the galaxy, and so on. So the whole universe is always in motion. And in a sense, that's another type of infinity, because think about when you work with a drawing compass, you're using the compass, and to make a circle, you're actually rotating it. And that rotation stands, in a sense, for infinity going around, because it will never stop. Just like the Earth will never stop to rotate, the solar system will never stop to rotate, and maybe, who knows, there was never a beginning. But that's another philosophical question. Now there's another one, and this is the most important one because today it's about fractals. There's another type of infinity, and we call it the infinity in a boundary. So just imagine you're starting with a triangle, and actually I'm going to go into detail more, but you can actually always place another triangle outside, you can get a smaller triangle, put another triangle outside, and so on. And why it's in the boundary is because you can infinitely fractalize this pattern, so making more and more smaller triangles inside, but it will never go over, in this case, a hexagon. Yeah, so this type of infinity, it kind of defines a boundary, and that's really important. Yeah, when it comes to reality, because, for example, even your skin, you could say that you could go infinitely small, but still there is some sort of boundary that doesn't let you pass through the skin, right? But how does it look like in shape? So just take, for example, a triangle and a square, because these are very simple shapes. And as you see here, we've just divided them each side, find the midpoint, so the division into 2, we would say. And by doing that, we can create another triangle inside for a square. You can make another rotated square. And then inside you do this again, you find a midpoint, and again you can create another square inside, and so on. So you could continue doing this into infinity, and you will never ever reach the central point. Right, that's the infinity in. And at the same time, you could say you can use the same shapes and you can create the infinity in the boundary, which means we divide the sides into 2. So we don't find the midpoint here, we actually find, we try to divide it into 3, each side of the triangle or the square. And by doing that, we can then place another shape outside. So instead of going inside, we're actually going outside. And then we can repeat this mechanism again, like an algorithm, as I said. So this means that it will actually evolve into infinity, creating more and more information, yet it will never cross a certain boundary. And that's really important when it comes to reality. Here, for example, you see it. This is the so-called Koch curve. So how this actually evolves. So you start from one triangle, get more, and it will go into infinity, and that's a fractal pattern Where do we see it? We see it in snowflakes. Yeah, a lot of the snowflakes, and by the way, especially if you expose them to very beautiful music, so the beauty also in sound helps them to form certain geometries and certain hexagonal shapes, and they're all different. They're infinitely different. None of them are the same, but they all follow this pattern of being inside of a boundary and creating infinite patterns. And where do we actually use it? Because, fractals, you find them a lot in nature, but the more we understand nature, the higher, is also our knowledge going in terms of what can we create for humanity that is more efficient, and create more and more better technologies. And one of these things that exists based on fractal geometry or fractal patterns is a fractal antenna. And this is very different to a normal antenna because here, the frequencies can be picked up in an infinite way because there's always another space. Just as you see in geometry, there's always another space where the information can be received. So fractal antennas are much more efficient in that sense and can receive much more information. So if we just summarize this fractal geometry, and that's also another very famous guy, Benoit Mandelbrot. He's a fractal inventor, and you see his image in the background, which in a sense is the same. You can go into every single corner of that image and it will just reoccur the same image and just always go into infinity with a similar kind of image or geometry. And it's all built on a certain algorithm. So he was saying that fractal geometry is not just a chapter of mathematics, but one that helps every man to see the same world differently. Well, that's a very philosophical concept, right? It's because, in a sense it is. We have infinite possibilities to see the world, and we all have our very unique perceptions. But I want to just mention one more guy here because I find him very important. Georg Cantor. He's a German mathematician, and he's born in 1845, and he's known for many, many different concepts regarding infinity, just like the set theory and the mathematics of infinity, infinity of infinities, and transfinite numbers. But we're not going into so much detail, but there's just one thing that I want to mention here because he was quite a philosophical guy. Because, on the one hand, it was always like, in the philosophies, it's like God must be it must be infinite. And he was one of the first persons who started to try to understand infinity through mathematics. And in this sense, he got a lot of opposition about this in his life because making infinity all of a sudden tangible seemed to be maybe opposing the churches and so on. But what he did was quite amazing. And that's just one of his findings. So basically, you have a number line and it goes infinitely positive, like +1, +2, +3, +4, 5, 6, 7, and so on. You can count into infinity, right? Onto one hand. And then on the other hand, you can do exactly the same on the negative side. Yeah, so -1 and +1 cancel each other out, 2, -2 cancel each other out, and so on. And this goes into infinity, in the sense the infinity positive and the infinitely negative. And in a sense, what we said on that number line, that's kind of what we say is the infinity out. It's going into both directions from the central point, your dot. But at the same time, between each whole number, the natural numbers, so between, let's say, 1 and 2, you actually have another infinite set of numbers. Because you can divide, let's say between 0 and 1. So you divide 1 by 2, you get a half. But you can divide 1 by 6, but you can divide 1 by 8, and so on. But you can actually find more infinities between 0 and 1 than there are whole numbers on the number line. Because let's say you can divide 1 by 1.8, you can divide by 1.888. Yeah, so actually there is so many more infinities happening within the spaces that it gets quite crazy in your mind. So which means that there is an infinity within an infinity. And that's a mind-blowing concept, actually. Which means, in a sense, for you, within every point of your experience, there could be an infinite expression of reality just between the spaces, in a sense, right? And yeah, this is a quote from Georg Cantor, and he said some infinities are bigger than other infinities, and that's definitely true because yeah, between the numbers 0 and 1 are more infinities than between 0 and the infinite positive and infinite negative whole numbers. And that is quite a mind-blowing concept if you think mathematics is the basis of nature. What does it actually mean? Okay, so what did we talk about today? Yeah, we talked about that there are basically a lot of patterns in nature, and some of these patterns exhibit certain patterns that repeat and repeat on every scale, just like the Romanesque broccoli. And that pattern stretches out through different scales of the universe, actually. And you can find it in the way that trees branch off. It's the same pattern than the rivers when they branch off, and your lungs, thunder, and that branching off itself is a fractal line pattern because it just repeats the pattern just like an algorithm. And that idea is actually based on certain geometries. You could say in geometry you have different types of infinity. There's not just one type of infinity. And these different types of infinity express themselves like infinitely in, which means like a dot, it's just going smaller, or the infinity out, going bigger and bigger and bigger outside towards the universe. I mean, that's normally the infinity that we all probably see or relate with. And then there's the infinity that just describes the circle. We had two different types of infinity, inside of a circle and the outside, which just basically tells us that the circle, in a sense, is an infinite-sided shape. And the circle also holds the idea of rotation. So we know that the universe, in many cases, is rotating. Yeah? Even the atoms, even the electrons, are rotating around the nucleus. Not exactly like that, but let's say schematically, yes. The solar system is rotating, the planet is rotating, and in a sense that represents also time, because time, we watch time in terms of watches, and they go around. Every 24 hours we have a new day, and in a sense even time, you could say, is in a sense infinite. And then we had the infinity in the boundary, and that was in a sense our link to fractals, because we know that certain shapes like the triangle and the square can go infinitely in, but they can go also infinitely out within a boundary by dividing the sides through particular divisions. 2 goes into infinity in, and 3 goes infinitely out. And that shape we found it in snowflakes. So snowflakes exhibit, in a sense, that kind of fractal line pattern, the hexagon, and in a sense that triangle branching out into infinity there. We know that understanding that these kind of concepts can help us with our technologies, for example, the fractal antenna, where we can, this antenna can basically receive more information than normal antennas, because if you use something that is fractal and infinitely taking information, you obviously have more efficiency in taking information. And in the end, we said that Georg Cantor was one of the big guys who was studying the mathematics behind infinity, and one of his concepts was the idea that there are more infinities between 0 and 1 than there are whole numbers, or natural numbers, in the universe. And that is quite an interesting thing when it comes to philosophy, because in a sense the infinity has always been related to God, but in a sense it doesn't exclude the idea of a divine creator, right? But what it means is that reality itself is somehow expresses itself through these different types of infinities, and to give us probably a reality experience that is quite finite. And in a sense, what is the message for you? I think it's quite clear. We all have an infinite potential to draw out something from the infinitely in, the dot, and create infinitely different things within the boundary of the Earth. I wish you a great day, and I'll see you next week.